Hello guys, this is Uncle DJ from Mathematical Series for Junior and Senior Secondary. Now let us go to the next one. Let's use another method to find the HCF of three numbers. Now let's find the HCF of 45, 60 and 75. Now we use this method. This is another method that you can use to find the HCF. What we do is you write 45 here, write 60 here, and write 75 here, and look for a number that can pull through or can divide any of the numbers. You run it through. Now let's take 2. We are taking 2 because one of the numbers is even. Look at this. This one is an even number because it ends with 0. But these other ones don't end with even numbers. So, but this one ends with an even number. So let's start with 2. 2 is the first prime number that we know. So let us use 2 to divide. 2 in 45, it will give us a remainder. So we don't divide it. We just write 45 down. 2 in 60, 2 in 6 is 3, 2 in 0 is 0. So it divides this. 2 in 75 is not possible it's not possible because it will give us a remainder. So we still write the 75 down. So but you can see that we can still use 2 to do the division because this is an even number. So 2 in 45 is still 45. 2 in 45 is not possible, so we write 45. 2 in 30 is 2 in 3 is 1, remainder 1. So we put 1 here, it becomes 10. 2 in 10 is 5, that's 15. So 2 in 75 will give us a remainder. So we don't divide it, we write 75 down. So 3, now let's try 3 because there's no even number anymore. So let's try 3. 3 in 45 will give us what? 3 in 4 is 1, remainder 1. Because 3 times 1 is 3, remainder 1 to give us 4. Now, we now put that 1 remainder, you put it here, it becomes 15. 3 in 15 is 5. So we write 15 here. We write 5 here, it becomes 15. 3 in 15 is 5. 3 in 75, let's do that step by step. 3 in 7 is 2. 3 times 2 is what? 6. Remainder 1. We put 1 in front of this 5. It becomes 15. 3 in 15 is 5. So that means we write 5 here. So you can see that this particular 3 divided 40, this 3 divided 45, it divided 15 and divided 75. So we will mark this number, or we highlight it, that because it went through the 3 of them is a common factor. So it's a common factor. So we highlight this guy, or we circle it. Now let's try 3 again. 3 in 15. 3 in 15 is 5. 3 in 5 is not possible. So we write 5 again. 3 in 25 is not possible. So we write 25 again. So what do? We don't mark this because it didn't divide 5 and it didn't divide 25. So we don't mark it, we don't circle it, or we don't highlight it. Now let's try 5. 5 in 5 is 1. 5 in 5 is 1. 5 in 25 is 5. So you can see this particular 5 divided this 5. It divided this 5 and divided this. So it's a common factor. So we highlight it, or we circle it. So let's try the last one. Let's try 5. 5 in 1 is 1 because it cannot go through. 1. 5 in 1 is not possible. So we write the 1. 5 in 5 is what? 1. So we cannot highlight this 5 because it didn't work on 1. It didn't divide 1 and it didn't divide this 1. But it divided only this one. So we can't highlight it. So the two numbers that went through the 3 of them that were common factors is 3 and 5. So the HCF becomes equals to 3 times 5. This 3 times 5, which is equals to 15. Or you can leave it as product of prime factors, which is 3 and 5. So the answer is actually 3 times 5 or 15. So that's a method, another method for working on HCF. Now, based on what we have just done, I want to do this using this method to solve the HCF of 30, 92, and 74. Now let's work on another method for doing the HCF. This HCF, find the HCF of the following. Use the index notification format. Now 128, 120, and 156. To do this, let's use another method different from the previous method. Now in this particular case, we are going to be finding the prime, we are going to be using the prime factors of each number. prime factors of each number. So we find the prime factor of 28, we find the prime factor of 120, we find the prime factor of 156. Then we now compare them. We now find what is common. So we write 128 here and find the prime factors. So this 128, this ends with the even figure. So we use 2 first. 2 in 1 is not possible. So what do we write? We don't write anything. We combine the first and the second digit together to become 12. 2 in 12 is 6. 2 in 8 is 4. So that's so now it still ends with an even number. So we use 2 again. 2, which is the first which is the first prime number. 2 in 6 is 3. 2 in 4 is 2. Right? So it still ends with an even number. So we use 2 again. 2 in 2 is 1. We have come to the end of the division. So 128 is equals to, in prime factors, is 2 times 2 times 2 times 2 times 2 times 2 times 2. We write it out here. Now let's do the second number, which is 120. 120. 2 in 1 is not possible. So what do? We put the first figure and the second figure together. 2 in 12 is 6. We write the 6 down. 2 in 0 is 0. We write the 0 here. 5 in 5 is 1. So we have come to the end of this one. So 120 is equals to 2 times 2 times 2 times 3 times 5. You understand? As a product of its prime factors. Now, let's try the last one. 156. 2 in 1 is 0. So we put the first two digits together. 2 in 15 is 7. 2 times 7 is 14. It's not up to 15. So remainder 1. That 1 we add it to this 16 and to this 6 to become what? 16. 2 in 16 is what? 8. So that's that. 2 can go again because it ends with an even number. 13, 3 cannot go in 13. Only 13 can go in 13. So because it's a prime number, so we use 13. 13 in 13 is 1. So 156 is equals to 2 times 2 times 3 times 13. Now that we have been able to break down each and every of this number into prime factors, we can now find the common number between the three numbers. Yes. So you can find that 2 is here, 2 is here, 2 is here. So that's 2 is common. Then another 2 is common. Can we find 3 everywhere? No. We can find 3 here, we can find 3 here, but we cannot find 3 here. So we don't use this. So it's only 2 and 2 that is common. So what do? HCF is equals to 2. The whole of this one you represent as 2. The whole of this one you represent as 2. So HCF is equals to 2 times 2, which is equals to. So the final answer is 2 times 2, which is equals to 2 squared. Now that we have solved this example, I want you to use this same method, this new method, to calculate or the HCF to 180, 210, and 270 using this new method. The very next lesson that we are going to be working on is how to calculate the LCM, the lowest common multiple of a couple of numbers or a series of numbers. In that particular lesson, I'll be showing you the answers to this home task that I've given you just now before we start that video. So make sure you try as much as possible to check out that video. I hope this lesson was helpful. Thank you for watching and have a great day. See you in the next lesson. Thank you.